Hi everyone, and welcome to my first workshop. I must say that it's the first time that I'm using whiteboard, so this is gonna be interesting experience because it's my first time experimenting with this tool, and I hope you can see that I'm also quite new, so I hope that it will evolve with the time. So this is a little video caster workshop on math, specifically big ideas around math in early childhood. So something that I am passionate about, and I learned a lot during my study as a Bachelor of Early Childhood and Masters, and something that I used to do as a tutor. So I used to teach young children early math, which was more like play gamified approach, I would say. Not free play, but more like intentional teaching, however in group context, so using social constructivism and problem based. So today, as I said, I'm gonna just provide a quick overview of what math is in early childhood context, and what comes to mind first when we think about math is numbers. Yes, so that's why I did write 1, 2, 3 here. And I think it's very strong still to have this understanding of math as numbers. So math is of course not just about numbers, and early math in early childhood education context for children under 5 is definitely not just numbers. First, because numbers are quite complex for children in terms of learning, because they're abstract and they're symbolic, but also because it's not just that. So they, during these first years, they learn counting, of course, and they do learn about numbers. They learn to recognize numbers, sometimes write numbers. They learn about some operations. Some children can actually understand timetables by the end of early childhood. Some children only will learn how to put numbers in order. However, this is something that they have a potential to learn. Measurement, geometry, is something people always forget when it comes to math. Matching, sorting, data analysis, and even algebra, which is called early algebra, and introduction of chance. There are specialists who, of course, do have a lot of workshops on early math. However, this one is more like an overview from the position of a teacher and teacher's trainer as well. So what is important to remember, so some key ideas before we get started with some more practical stuff. So we will start with the big idea of development here. So as you can see, so development is, as you know, something that happens across all lifespans. So, but we are focusing more on early childhood development, specifically cognition, cognitive development, or development of thinking, memory, perception, attention, concentration. So all these things are important for math, and they do develop independently, but also are influenced by other areas of development. For example, if child doesn't speak, so the language would not be involved in thinking, and there is a strong connection between language and thinking. Yet it is possible to help child to learn about math just through different ways. So development is happening across all domains. For example, physical development also required for understanding math, because it's moving through space that can develop spatial awareness better than, I guess, abstract learning about spatial things. Problem solving is another thing that quite often is not considered when we think about math, but it also requires cognitive development. So that's why I'm going to add here, very important thing, cognitive development. Yeah. So that's the key aspect of math. Next thing I wanted to talk about was theory. So theories, it's a lot of theories around childhood development, and one of the theories is well-known theory by Jean Piaget. So we're gonna go down this mind map. So Jean Piaget was, as you know, Swiss developmental psychologist and biologist as well, who developed the theory of cognition, so cognitive development, and he also was one of the important influences in terms of childhood development in general, because he was also doing a lot of great observations. So in his observation of development and thinking of children, he noticed that children think differently. I think it's still relevant, although the theory was developed a long time ago and considered to be classical. He also developed a theory based on so-called maturation, or development of child through stages. So each child, no matter where you're born, you will go through certain stages of cognitive development. So first one is sensory motor. So when you will be actually learning about the world through exploring it, so through senses and moving your body in space. I think this is very important for us as teachers, especially of young children, infants and toddlers, because they need to touch the resources that are related to math. They need to move to be able to understand it because of Piaget theory. Another important point he said about, and this will be relevant to math, stages and ages. He was saying that children go through stages of development and they achieve certain level of development. Before that, they are unable to understand certain concepts. So there are some limitations in their understanding, and one of the key limitation related to object permanence. So children learn to understand that objects do not disappear when they are gone. Something you can check on YouTube. And another limitation is that children need to learn about conservation. So conservation. The other thing might be about children not being able to understand abstract concepts, as I said, until certain age, and also that's why they need manipulatives. So that's why they need to operate different resources. So jumping ahead, you can look at some examples here. For example, children need water, so which is a sensory experience, and they can move it and manipulate and play with water to learn about quantity and volume, etc. So on picture 6, you can see that children may use different sticks and rocks and other objects or plates to learn about counting and order and sorting. Shapes, better to be taught through real shapes, not pictures of shapes, because of, again, these stages of development by Piaget. So the other thing is that the materials and resources should be very, very different. And they should allow children to manipulate them. So if, as you can see on picture 6, which is probably repeating another 6 number, someone has problems with math. So you can see here that this one is full of interesting concrete objects, and also set up for 2 children, so they can both explore calculator, clipboard, and try to write numbers or copy them. They might look at stones, little rocks here, and they also have abacus. And they have scales. So the range of different resources. So this Piaget, and it's very important to understand Piaget ideas when it comes to math, in order not to jump ahead and give children something that they're not able to process, or push them to learn abstract concept when they are not ready mentally, cognitively. Another great influencer would be Bruna. So I don't have a picture of him, but Bruna is well known for his theory of social learning, Yeah, and as you can see here, he talked about discovery learning, which means that children actually discover things. It's slightly different from Piaget theory, but also in line with Piaget developmental theory, which means for us that children will discover a lot of things about the world while walking around, manipulating objects, gardening, and doing a lot of things. He also said that children need a lot of practice, so a lot of repetition in order to learn through discovery. And of course, this means that they need to have a lot of beautiful things. For example, if we are talking about garden, so they have to have access to beautiful flowers and rocks and other beautiful things. If it's indoor environment, we should provide them with a lot of interesting toys, manipulatives, and just resources. Another type of learning Bruna was referring to is quite new for many of educators, or they forget about it, and it's called assisted learning. Yeah, assisted learning is a very interesting type of learning, as you can imagine, requires another one, so someone. Which brings us to a next theorist, which is in line with what Vygotsky was saying. So everyone heard about Vygotsky. Vygotsky is a theorist in early childhood, very influential. Unfortunately, died when he was 37 or 38, so very young. So Lev Vygotsky was saying that children actually, in order to understand math and anything complex, they need to develop higher order mental functions, yeah, because we do have lower order mental functions, and usually these are functions of our mind that are not deliberate. So children do not really control it. It's developing, and higher order functions, mental functions, usually develop through this help of a so-called more knowledgeable other. So MKO, yeah, and this might be like usually a grandfather, a teacher, another student, a peer, an older brother, mom, yeah, so anyone. So more knowledgeable other. So this person helps to introduce some concepts for a child through language. Yes, so we do talk to children. For example, a baby is born and we start to talk about like we are basically math, yeah, but we interact with children and we start counting. We say 1, 2, 3, 4, 5 and sing songs that include numbers. We might count fingers when we are playing, engaging with the baby. So language supports development of higher mental function, introduces math language, and actually introduces a lot of interesting activities as well that children are involved in with adults. For example, gardening might be musicking, making music might be going for a walk, counting steps. So you all can recall some kind of examples when language was a tool for learning some new, and I will add it here, concepts, yeah, or skills. So the role of language is very, very important, and that would be a focus of one of the sessions that we're going to talk about. Also, Vygotsky was saying that unlike Piaget, development leads learning, so a child needs to mature until they reach this stage when they will be able to understand concepts that are abstract like numbers, and to be able to understand, let's say, additions and other operations. Vygotsky was saying that learning actually leads development. So children learn in context of their society or culture, so with those more knowledgeable others, with adults, and with help, with assistance, they can actually learn more. Yeah, and I think it's very applicable to math, especially if we consider math as not just numbers or counting, but early operations, measurement, geometry, sorting, data analysis, algebra, and patterns. Yeah, so all these important things that we mentioned. So this happens in context. That's what Vygotsky was saying, and it happens in context of social interaction and in culture. So in context of culture. Two other theorists who really liked Vygotsky and started to develop his theory further, Bodrova and Leon, talk about mental tools, and they tried a lot of great tools with kindergarten children and older children in America, and what they discovered that this person who is more knowledgeable other can actually help children to achieve higher order mental functions through the use of so-called mental tools. Mental tools might be anything from adult helping child to count by using like little props, like those teddy bears, or little figurines, or rocks, or any kind of natural materials, or it might be a card with a number. So that's what I use as a teacher. I really like to use those prompts. And what happens is actually through language as well, and through the use of these tools, children are able to understand concepts that otherwise are a little bit hard to understand, because they are concrete learners as well. So they need practical tools according to this theory as well. Everything children learn happens in the context, and that's how we need to understand that all children who come to our centers or children who we're supporting learning of might have very different actual zone of development or actual math skills. So in other words, some children will be able to understand what 20 is and understand quantity, while other children would not even understand the difference between 1 and 2. Yet some children will have better spatial awareness, and other children will be able to match better. So it's all because of practice and the context of their development, what they've done at home, what they've been doing, what are their experiences in life, and also, of course, their level of development. Yeah. So since learning leads development, there is no harm in showing children some more complex things, as long as the learning is within this so-called ZPD, and I'm going to highlight it, or zone of proximal development. Yeah, that's one of the key concepts of Vygotsky, zone of proximal development. Again, you can watch more videos on zone of proximal development, or we can have a separate session on that. But ZPD, or zone of proximal development, talks about actual development of the child, what they can do by themselves. So, for example, a child can count to 1, yeah, and with adult they can count to 10, yeah. So what's in between is the zone of proximal development. So the next step would be to count to 5, let's say, yeah. So unassisted, or then with assistance. So do it a few times until child will actually understand the concept, and then you can kind of remove your help. That's all important for overall picture of math and teaching math, or learning math and helping children to actually learn it. A few other things you might actually find interesting here is like about big ideas. For example, math, as I said, it's not just numbers or counting. It's also about symbols. So understanding the development of symbols or stages of symbol recognition is important to make sense of what you teach. So children actually exposed to many symbols, for example, pictures, object symbols of words and letters, number symbols, and the development of these concepts also depends on child's maturation, so how mature they are, so whether they developed brain structures for that and processes, and also the influence of their context. Remember, the more knowledgeable other person. So that's something to consider when you are setting up an experience or thinking about what can you teach or what is too early to teach. Another thing is spatial awareness, so child in space, or where am I, so understanding where you are. So that's some few concepts here: enclosure, proximity, you're near, far, order, so first, second, yes, so etc., and seriation. So I made a mistake here. Seriation. So that's just one of the concepts you can explore in early childhood education context. The other one is well-known: numbers. Usually children start to learn about numbers when they are quite young. So for example, they hear spoken words, yes, so and spoken numbers, and the example would be 1 2 3 4 5, once I caught a fish alive, or similar songs. This little piggy went to market, this little piggy, and then 1 2 3 4 5 6 7 8 9 10, just counting of steps or whatever parents are doing with child. It might be cooking, so any kind of experiences that involve spoken words. Yeah, then they start counting, apparently, because they love to show their skills, and they're also, I think, supported by parents. But most of this counting, and that's very important to remember, is rote counting. So rote counting means the child does not have a good understanding of quantity. It is a good first step to next type of counting, which is called rational counting. And to support this transition from rote counting to rational counting, it's important to introduce a lot of resources and teach children counting through materials and concrete materials, for example, loose parts, so such as buttons, sticks, rocks, whatever. So whatever you can count. So if we think about cooking as well, so that's a routine that all families do. So that's a perfect routine for learning about numbers and counting in context. So packing up as well and counting with a child. Shopping also helps to develop rational counting when child understands the quantity. Dressing up, going up the steps, yeah, or down the steps. Intentional teaching is another thing you can do, and that's the whole new topic, but that means that you will be introducing the concepts through the routines, or teaching numbers in more formal context, or planning experiences with the concept in mind, to introduce rational counting when child understands the quantity and the idea of quantity. Some examples of intentional teaching might include music. So as a big fan of musical curriculum, so in early childhood, I always use music. For example, we do clap our hands, we sing, we tap our feet, we use musical instruments such as drums, sticks, etc., etc. And this all helps to learn numbers, but also learn about counting in a more rational way. So some children will still be using rote counting even when they're singing, but music itself promotes more deeper understanding of symbols, of rhythm, of even matching, yes, so, and all the other important things. And there are special concepts that are definitely related to math, which I don't want to cover in this first introductory session. So some examples here from the pictures that I collected. So the child plays outside and just tap sticks on a musical instrument outside. Another example would be having in baby's room or toddler's room, having just lots of musical instruments so children can shake, tap, etc. The other thing you can consider as well is the development of matching as a skill. So first children understand what is the same. So, and this starts with a doggy, or even understanding that I look similar to another child. Yes, so there are some similarities, like let's say my hair are dark and her hair is dark. Then they move on to understanding matching shapes. That's quite common activity. That's my niece playing with matching toy. Attributes, so they learn about sorting. For example, they can put like circle one here, triangle here, star here. Ordering, yes, so that's putting them in logical order would be the next step. So it makes sense to introduce them slowly, yeah, and watching children development of basic skills before you develop higher order mental functions and develop skills that are more complex, of course. So that's another rule with math. You introduce first simple concepts and then you move on to more complex concepts. And the last thing is to remember this saying by Vygotsky that learning leads development, which means that we have as theorists and as teachers to have a very, very good understanding of how children learn in order to give them resources that they can learn from, and also enrich our routines and enrich our teaching through very, very thorough understanding of child development. So it all goes back to child development, and it all goes back to theories of development and brain development. So make sure that you do go back to your theories. Consider Karen Cairns' book, Birth to Big School, to revisit those big theories of Bruna, Vygotsky, and Piaget. To consider how you can apply this to big ideas around math in early childhood education. Thank you for listening. I hope you enjoyed this whiteboard presentation. So please comment and tell me what you think. Next time we will discuss more practical ideas and we'll focus on strategies or teaching and learning about math.